Hey everybody, we are on section 15.2 and this section is on what's called the law of sines. And I'm going to teach you how to use the law of sines, but before that, I'm going to do something a little bit different. I'm going to introduce to you why in the world we might ever use this, okay? So hang in there with me. To start off, I'm going to introduce you to some of my favorite things here around my own house. Are you ready? Introducing Millie, Oreo, Minnie, and Daisy. These are some calves that we have, and there are my kids. We're bottle feeding them. So much fun. Aren't they so cute? I did not grow up on a farm, and I just think this is the coolest thing ever that we have these calves that we get a bottle feed. So we have these calves. Now, what's a really good place to keep these calves? You want a barn, right? You want a nice barn. So before purchasing these calves, having a barn is a nice thing to have. So when we talk about, say you're a farmer and you want to get you some calves and you go, well, I need to build me a barn. Well, take a look at this barn. When we do this, okay, whether you design it yourself or whether you have an architect help you, take a look at some of the things that they might have to figure out. So you decide, first of all, how big you want your barn to be, right? You're going to decide the total length of it, right? That's going to be important. You can figure out the total height that you want. You can figure out kind of these proportions. One piece that uses a lot of mathematics is when you get into these triangular pieces. So see this very top peak of this barn? What happens is architects look at that and they say, okay, we know the width, so they know the distance between those 2 points down below. So they know this length. They'll just determine how wide they want that to be. And then what they do is they determine what is the best angle for the peak of this roof. They look at it and they really figure out what is the most pleasing to the eye. What's going to look best? Do I want a peak that goes really steep up here? And they go, maybe not. That might be too steep to do something like that. So they go, all right, well, do I want a really flat one like this? Well, that might be okay, but you know what? I really think an angle that's right about here is what I want for the look of this. And that's what they'll do. They'll figure out the angle measure that goes right here and right here. So they know those two angle measurements, and they know the distance from here to here. But remember, so far you guys have only used right triangles. We can use SOHCAHTOA when we have right triangles, but this is not a right triangle. So these architects use mathematics and specifically this law of cosines so they can figure out how long this piece of the roof is going to be, because that's important for the builders to know so that they can then do it. Okay? Just give you another example. I'm going to give you another couple favorite things around the house. We have some new baby kittens. Look at these little kittens. They run all over and are so fun right now. And suppose I don't want these kittens to mess up my house. I don't want to have them inside. So what am I going to do? I'm going to put them outside. But I love my kittens, so maybe I will consider building them a really fancy cat house. Wouldn't that be cool? I love this little cat house. And in building this, okay, so my husband and I decide we want to build this little cat house. What are some of the things we're going to need to decide? Well, one of those things is the dimensions, right? We can determine, once again, it's a lot like the barn. Okay, how big, how long, and how tall do we want those pieces? And then what do we need to decide? The pitch of the roof, right? The pitch meaning the angle of that roof. We want to know what we want this to be, right? And to do that, we create what angle measure we think would look the best. And then we use mathematics to find this. So in doing this, remember, there really are real-world applications. I have helped my husband build things, and guess what? I have used math so many times in things that we have built over the years. So these really are applicable mathematical theorems that I'm teaching you here. And today is law of sines, and tomorrow's law of cosines. The big thing to remember with these Oh, I had another picture for you. I forgot. So again, as an architect, say you're designing a house and you need to be able to tell the builder the dimensions. Take a look at all these. They're going to have to figure out that triangle. Then they've got to figure out this triangle. They got to figure out this triangle. They've got all kinds of pitches over here that they got to figure out. So it gets more and more complicated, but not really. They're just using the same thing over and over. But in the end, the main thing I want you guys to remember is when we use the law of sines and law of cosines, these are specifically for things that are not right triangles, okay? That's where these come in handy. What do we use if it's a right triangle? We use SOHCAHTOA. All right, that's the easiest, fastest way to find angle measures and side measures is SOHCAHTOA if we have a right triangle. If it is not a right triangle, if it's not, then we're going to use law of sines and law of cosines that you're learning today and next time. So let's go to the note packet. So if you've got your notes for 15.2, we're going to go through those examples and actually show you what the law of cosines is. Okay, here we are in the notes, and we're going to talk about what is the basic law of sines. So remember, this is for any triangle that is not a right triangle, right? So let's just draw us a triangle. And this is some triangle ABC. So this triangle ABC, remember to label the sides is always the lowercase of the angle across from it. So to label this side right here, what angle is it across from? Is across from angle A. So we label this side little a. Okay, across from angle B, this side right here is called little b. And across from directly opposite angle C is little c. So when we talk about the relationship of the three angles and the three sides, the law of sines tells us that we can take the measure of side A over the sine of angle A. And that will be equal to side B over the sine of angle B. And that is also equal to little c or side C to the sine of angle C. Now you will typically not use all three of these at once. It's all dependent on what information you're given. So maybe you will use the A's and the C's, or maybe you will use the B's and the C's, or maybe you will use the A's and the B's, but we typically will not use all three of them at once. Okay, now the big important thing is in order to use law of sines, you need to start out with a matching pair, meaning you have to know a matching pair. Maybe you know little a and the measure of angle A. Or maybe you know little b and big B. Or maybe you know little c and big C. You have to have a matching pair in order to use law of sines. So that's the really big takeaway is that you need a matching pair. Okay? That's how you know you want to use law of sines. So take a look at example 1. Find the measure of angle B. Okay, I can use the law of sines if I have a matching pair. So take a look. Do I have a matching pair? An angle and the side opposite it, I have a matching pair. If we have a matching pair, check. We can use law of sines. Okay, so let's label our triangle. This side is little c, this side is little b, this side is little a. So what am I going to use? I'm going to use c over sine c because that's my matching pair. And then what is I want to find? I want to find angle B. So I'm going to use, the other pair is going to be the B's. So I'm going to use equals B over sine B. And now we plug in our information. Little c is 21 over sine of 99 equals little b is 10 over sine B. Angle B is what I'm trying to find. So once you set it up, you should only have one variable. Okay, you cannot solve this with more than one variable at once. So make sure you only have one variable. Now, we went over in 15.1, how do we solve a proportion? What do? We cross multiply. So we are going to cross multiply this direction. How do I do sine 99 times 10? We are going to type in a calculator, but just not yet. Okay, so hold off on that. And I'm just going to write it as 10 times sine 99. Now, if you wrote it the other way, sine 99 times 10, it's the same thing, right? And then I cross multiply the other way, and that makes 21 times sine B. Now, I gave you some equations in 15.1 on how to solve, okay? How do I solve for B? What do I need to get rid of? I need to get rid of the 21, and I need to get rid of the sign. Order of operations says which one do I get rid of first? I get rid of the 21. How is he connected? By multiplication. So I'm going to divide both sides by 21. Now at this point, I am going to type all this into my calculator. So if you have your own calculator, go to that. Otherwise, I just found this online, calculator.net. Works awesome. It's got everything I need. So I'm going to come here. I'm going to type in 10 times, I need to be in the scientific mode. My bad. 10 times sine. Now I want normal sine. Okay, make sure you click on the normal sine, not the inverse here. Regular sine of 99. And make sure you're in degrees, because that is in degrees, 99. All right. And I either need to close the parentheses before I do the divide by 21 or hit equals and then divide. But I'm going to close those parentheses so that I make sure that's my angle is 99. And then I hit divide by 21. And when I hit enter, I get this 0.47. Now we're not going to round yet, but just so you get an idea, I have sine B is equal to 0.470327, and I can keep going, right? We're not going to round until we get to our final answer. So remember from 15.1, how do we get rid of sine? What do I do to get rid of sine? I take sine inverse of both sides. So I take sine inverse of both sides. These will cancel, leaving just B. That's what I want to solve for. That's good. And what's over here? Sine inverse of my 0.470327, da, da, da. I'm going to show you a trick on this calculator. Are you ready? If I already have this up here, then what I can do at this point is say I want to take the sine inverse of that answer that I had right before. If you hit that answer button, look what it plugged in for me. 0.470327. It was that number that I just had. So it saves that answer for you, and you can use that button to help you find it. And now my final answer, we'll round it to the nearest tenth, is 28.1. Now we're finding the measure of angles, so this would be degrees. So I can find it by using this law of sines. Okay, let's try one more example here. Number 2, it's a word problem, but it's already got the picture drawn for us, so that's helpful. 2 searchlights on the shore of a lake are located 3,020 yards apart as shown in the diagram. A ship in distress, here's our ship, is spotted from each searchlight. The beam from the first searchlight makes an angle of 38 degrees, so there it is, with the baseline. The beam from the second line makes an angle of 57 degrees with the baseline. Find the ship's distance from each searchlight. So they want me to find this distance, so we'll call it X. They also want me to find this distance, we'll call it Y. Okay? So we're just going to solve one variable at a time. Not both of them, just one at a time. So let's just start with X. Now, if I want to use law of sines, what do I have to have? You have to have a matching pair. Okay, let's look at my triangle. Where is my matching pair? Oh, bummer. This has a variable. I have to have a matching pair where I know both the side and the angle. So I can't do X and 57. I can't do Y and 38. And this one, I don't have the angle. I'm stumped. There's got to be a way to figure this out. Okay, can you guys remember? Important thing. What do the 3 angles in a triangle always add up to? They add up to 180. So if I know that this angle is 38, and I know this angle is 57, can I find this angle here? Yes, I can. Let's go do it. Go to your calculator. We're going to do 180. Oh, I need to clear that out. 180 minus 38 minus 57. Oh, can I go back? There we go. I missed my 5. 57, and I end up with 85. Okay, this angle's 85 degrees. Now do I have a matching pair? You bet. Right here, I have an angle, and it's matching side right there. Once I have a matching pair, I know I can do law of sines. So that's the trick. Don't ever forget that the 3 angles add up to 180. If they give you 2, boom, you can find that third one. Okay, we said we're going to solve for X, so we're going to use this matching pair, and then we're going to use X and its matching angle over here. So let's set it up. I take the side length, 3,020, over the sine of its angle. What was its angle? Straight across, 85, equals, now for this pair, I take the side on top and then the sine of the angle, which is 57 on bottom. So it's all about getting that set up correctly. All right, what do? Cross multiply. So I'm going to go this direction, x times sine 85. I have a habit, you guys, I always list the sine second. So that's just me, but you don't have to. It'll work out the same. And then this direction, 3020 times sine 57. Okay, my goal is to solve for x. How do I solve for x? Now remember, sine 85 is just a number. It's all one piece, okay? It represents just a single number, which means if it's being multiplied, guess what I can do? I can divide by the entire sine 85. And when I do, look, I've solved for x. X is 3020 times sine 57 divided by sine 85. Go to your calculator and let's type it all in. 3020 times sine 57, close those parentheses, don't forget that, divided by sine 85, hit enter, and I get 2,542 we'll round nearest tenth, 0.5. Now, is this degrees? No, we were not solving for an angle, we were solving for a side length, okay? That is the measure of this side. So the ship, that's how far away it is. It was in yards, so we could label that the ship is 2,542.5 yards from this light right here, okay? Now we can go and find the other one. Quick question. If I know this side, can I do a squared plus b squared equals c squared? No! Okay, Pythagorean theorem is only for right triangles. What are we doing? We're doing non-right triangles. This is not a right triangle. You cannot use Pythagorean theorem. So our only choice is to do this all over again. We're going to do law of sines all over again. So we're going to use this same matching pair that I started with. Could I fill in this number and use that as my matching pair? Sure, if you want to. I'm just going to stick with what we started with. 3020 over sine 85 equals, now I want to solve for y, so I'm going to use this one. It's always the side on top over the sine of the angle on bottom. Okay, now we cross multiply, go this direction. That's a y times a sine 85. Go the other direction, and that's a 3020 times sine 38. Okay, what's my goal? My goal is to get y by itself. So what do I need to get rid of? This entire sine 85. It's an entire number. So how do I get rid of times sine 85? I'm going to divide by sine 85. Okay, go to your calculator and type it in. We have 3020 times sine 38, close those parentheses, and then divided by sine 85. Hit enter, and I end up with 1,866.4. If you want to label it, that is also in yards. So that is the distance from the boat to this light. So you're going to have to do some of this on big ideas where the directions will say solve the triangle, and you're going to have to find all the pieces. So you may have to set up your proportions more than once. But that's how we do law of sines, and that's how these architects figure out the distance on the tops of the houses in those triangular pieces. It's kind of cool, isn't it? All right, you guys can do this. Finish strong this last week of school. Talk to you later. Bye.